Liquid-only roadway treatments are becoming increasingly popular as a tool for preventing the bonding of snow and ice to our roads and for removing snow and ice during storms. Public works agencies across the United States are using liquid-only treatments due to their ease of use, low costs, and fast response times. However, there are many misconceptions and misunderstandings that people hear about these types of treatments. In this video, we will discuss the benefits of liquid treatments, address common myths, offer tips for starting a liquid-only program, discuss equipment types, and show recommended usage parameters and application rates. In doing so, we will demonstrate why liquid-only treatments are a safe and reliable solution for snow and ice prevention and removal. What are liquid-only roadway treatments?
Liquid-only treatments are an important component of doing everything you can to minimize ice formation on the roads prior to a storm coming in here in the city of Prior Lake.
Liquid-only roadway treatments are used for anti-icing and de-icing. Anti-icing is a proactive treatment that occurs prior to the start of a storm event. It prevents snow and ice from bonding to the roadway surface. De-icing occurs during or after a storm to remove existing snow and ice, or to aid in loosening snow for plow trucks to remove. The liquid treatments are usually a brine solution of water and a compound, such as rock salt, sodium chloride, or magnesium chloride. Although these compounds both create salt brines, the term salt brine typically refers to a sodium chloride brine. These brine treatments can be used in place of solid salts or aggregates during certain weather conditions.
Liquid products are much more effective of getting us back to bare pavement, of burning off that last little bit of pack than opposed to granular products.
Why use liquid-only roadway treatments?
Liquids are easy to put out. They'll stay on the road and they won't blow off like a solid particle will. If you're going out and trying to anti-ice or get ahead of a storm with a solid granular material, good chance that's all going to blow off the road.
When you're applying liquid material to the roadway, it stays in the roadway, in the travel lanes, for the traveling public that you are trying to benefit. Whereas with granular material, even at the recommended 25 miles per hour, you are still going to have bounce and scatter. The traffic that's following behind that truck is going to remove that solid material from the roadway surface as they're driving along. Whereas with the direct liquid, it is applied, it is immediately working, and it is making an impact to improve our level of service to the traveling public.
When dry, solid salts are applied to a roadway, the granules can bounce off the road or can be blown off the road by traffic. Some agencies estimate that as much as 30% of the dry, solid salt in each application does not stay on the road. Liquid-only treatments stay on the road better than solids, which results in less waste and less salt going into the environment. Many agencies using liquid treatments have found that their overall salt usage decreases by 25% or more.
What you'll tend to see is liquid de-icing is cheaper than granular de-icing. There's a few reasons why, and the main thing is the usage of material. For example, you can spread salt brine at an application rate of 40 gallons per lane mile. Each gallon of brine has 2.2 pounds of salt per gallon in it, so you're at about 88 pounds per lane mile. Take that on the granular side, and an application rate is generally 250 at the bottom side and could range anywhere up to 350 pounds per lane mile. Studies have shown that the savings is at least 30% when you compare liquid versus granular.
If we can get liquid down prior to a light storm coming in, the cost benefit is not just in the cost of the chemical, but also in fewer truck trips not needing to come through and plow to keep the ice from forming.
Liquid-only treatments reduce the amount of airborne dust and salt particles. It is also easier to control the application of liquids, which makes the treatments more accurate. This increase in efficiency reduces the cost of maintaining safe roads.
Utilization of liquids allows us to say we can apply this product in a very metered, controlled fashion at the specific spots that we need it on the roadway to be very effective.
How do liquid-only roadway treatments work? In order for salt to melt snow and ice, it must first be dissolved into a liquid form called brine. With solid salts, this happens naturally as the salt interacts with the precipitation on the road surface, but it can take up to 45 minutes for this transformation to take place, depending on weather conditions. With liquid-only treatments, this brine is already made, and it begins to work as soon as it hits the roadway surface. Brine melts snow and ice by lowering the freeze point of water. This means that the snow and ice will keep melting even when the temperature is below its normal freeze point of 32 degrees Fahrenheit. Salt brine mixed to the correct ratio has a freeze point of -6 degrees. However, the salt brine will mix with the precipitation on the road, which will further dilute it. Most agencies use salt brine at an operating range of 15 degrees and above. Some agencies use magnesium chloride or calcium chloride brine instead of salt brine. They are a more expensive option, but they have a lower freezing point than salt brine. Depending on the concentration and manufacturer, some agencies use magnesium chloride or calcium chloride at temperatures as low as 0 degrees Fahrenheit. It is possible to blend either of these brines with salt brine to balance the higher cost with the benefits of lower temperature usage. In addition, there are other materials that can be mixed with salt brine to further lower the freezing point of water and to reduce corrosion. A listing of these materials can be found on the Pacific Northwest Snow Fighters website.
You can drop down a little farther with calcium and magnesium than you can sodium chloride brines. Their melting capacity is a little greater initially, so the mag chloride will melt material faster for the first 20 minutes than the sodium chloride will. At an hour, they're pretty much the same, one's just quicker.
Common myths about liquid-only roadway treatments. One common myth is that liquid-only roadway treatments don't work in extreme weather conditions such as heavy snow, high winds, and freezing rain. Despite this misconception, agencies across the United States are using liquid-only treatments in these challenging conditions. During storms with heavy snow, the liquid treatments may not be as effective at removing snow, but they are often used to loosen hard snowpacks caused by traffic, making plowing more effective. In a weather event with high winds, anti-icing with a liquid solution will stay on the road despite the wind, while solid salt could be blown into the ditch. In freezing rainstorms, depending on the projected intensity of the storm, a liquid anti-icing treatment can be used prior to the storm to keep the ice from bonding to the roadway. During the storm, the liquids immediately begin melting the ice. Additional liquid will need to be applied in order to counteract the dilution of the treatment.
But we've even shown on heavy icing events or ice storms that getting that product into the pavement down before that rain or that precipitation comes in, it still breaks the bond with the pavement and allows cleanup and traffic just to keep breaking that up. Yes, it dilutes out, but it still has a dramatic impact on not creating that base layer of ice on the roadway.
Another common myth is that using salt brine results in more chlorides entering local water sources than using solid salts. Chloride ions are a byproduct of salt brine, and high levels of chlorides can be toxic to aquatic life. However, in order for solid salts to melt snow and ice, they must first dissolve into brine. So in either case, brine is being used to melt the snow and ice. With liquid-only treatments, agencies are using less salt, which results in less chlorides entering the environment. This is especially true in locations where solid salts can bounce directly into sensitive areas. Using liquid-only treatments for anti-icing reduces the amount of de-icing treatments that are needed during and after a storm, which can further reduce salt use.
We run a toxicology test that includes looking at fish, aquatic insect, and algae, and seeing if it's detrimental to any one of those three species. So having that in hand helps us go through the approval process. But the biggest concern that I try to promote is do what you need to do to make the public safe, but don't go overboard so that you put too much salt in the environment.
I would say with any sort of salt storage, you need to do your best to protect the environment and the materials that you're applying to the roadway. You want to keep it in a contained area. You want to dispose of any of it properly. Salt brine, rock salt, all of that has consequences if too much is applied to the environment.
Public works agencies are working to reduce environmental impacts while still maintaining public safety. Many agencies utilize road weather information systems and road sensors to obtain real-time information on weather conditions. They use this data to determine where and when anti-icing and de-icing should take place. With this technology-based approach, agencies can further reduce their salt usage.
I think it's important to have something that'll give you a soil temperature underneath your road, a puck in the road that'll tell you the salinity of the product you're putting down and the road temperature, and have a way to monitor and go back after storms and look at what the process is you're doing and how well it's working.
Another common myth is that salt brine causes more corrosion on vehicles than solid salts. This myth is similar to the previous one regarding chlorides. All solid salts need to dissolve into brine on the roadway in order to melt snow and ice. As a result, roughly the same amount of salt brine is affecting your vehicle with either treatment. Some agencies add a corrosion inhibitor to their salt brine or magnesium chloride, but this still does not eliminate vehicle corrosion completely. For this reason, agencies frequently recommend washing your vehicle after a storm event.
In liquid products, we can correctly measure the corrosion inhibitor that's introduced into those products. There's still a lot of studies showing a corrosion inhibitor on a granular product is just not effective. As soon as that molecule kind of breaks down, the corrosion inhibitor disappears, whereas a liquid product that's mixed in is coating that chloride ion.
We do corrosion testing here. We do some wet bench work on things. We'll do pH. We evaluate corrosion percent effectiveness of products. Salt, as it stands, is 100%. It's at the top of the scale. All the corrosion-inhibited products have to be at least 70% less corrosive than rock salt.
Starting a liquid-only program. Starting a liquid-only program at your agency can be beneficial for your level of service and your bottom line. Most agencies have had success with starting their liquid-only treatments slowly and figuring out what equipment and methods work best for them. Consider starting with lower volume roads that are close to your facility. If you do not want to invest in a brine maker immediately, you could purchase brine from a vendor or a nearby agency while you start your program. Instead of purchasing all new equipment, it might be possible to convert or upgrade your existing equipment. Visiting other facilities that already have a successful liquid-only program can help gain buy-in from your team. Keeping your team informed and involved in the program can help turn critics into advocates.
The first thing to do is really define your plan and what you'd like to accomplish. After you understand what you'd like to tackle with it, the best thing to do is jump online and start to research it. After that, it's usually beneficial to try to work with somebody in your area. What type of equipment are they using? How are they applying it? How are they storing it? How are they making it? What successes have they had and what failures have they had? And you can really learn from that. And finally, work with a good reputable vendor. There's a lot of good equipment builders out there that are savvy in the business, and tie all that together and you can really gain some great information.
There are numerous online resources for liquid-only treatments, including the Clear Roads website. It is important to remember that liquid roadway treatments are just one tool in the toolbox, and they are only effective during certain weather conditions.
Go to some snow conferences and listen to the people, talk to a few of the sales reps. Most of all, talk to your state agencies or call the PNS or Clear Roads. Most of those people within the agencies there have pretty good experience in what's going on.
Equipment recommendations. The minimum types of equipment you will need include a brine storage tank, a loading pump, a discharge pump, and a truck with a tank and spray bar. Brine storage tank sizes and materials will vary, but most agencies have a minimum tank size of 5,000 gallons. And the most common types are fiberglass or polyethylene. Before choosing a tank setup, check with your local environmental control agency to determine what your state requires for containment.
In the last few years, there's been quite a bit of interest in fiberglass tanks. They're generally more expensive than a polyethylene tank, but they are a great alternative to polyethylene. So those are the two main options in the snow and ice market to date.
Brine has a higher specific gravity than water, so the pump and tanks will need to accommodate that. The tank should also have a minimum port size of 2 inches to allow for a proper flow rate. Many agencies prefer a 3-inch port size for faster flow rates. The minimum flow rate should be 110 gallons per minute at 20 psi. A preferred flow rate is 275 gallons per minute at 20 psi. The discharge hose length should be as short as possible. When choosing the port size, consider the applicator tank inflow line size. outflow line size, and valve sizes. These should all match the pump capacity. Most liquid de-icers are corrosive, so you will need to select a pump that can resist corrosion. Rock salt also contains stone particles that can cause excessive wear on pump parts, which should be considered when selecting your equipment.
We have high capacity pumps running through a 2-inch line. All of our trucks are set up with a 2-inch intake load out system.
We just use 115 volt pumps, just 2-inch, and we use a couple pumps per truck to load them. We're using like a swimming pool pump with a plastic body. And then most of our trucks can self-load as well with the hydraulic pumps on them.
There are many different options for liquid storage on the truck. Smaller trucks can be fitted with side saddle tanks or with one large tank. Dump trucks can have wedge tanks or slide-in tanks added. Large tanker trucks can also be used. Consider your route length and application rate when choosing your storage system.
There are numerous options for slide-in de-icing tanks, anything from 500 gallons up to 3,000 gallons that would slide into the back of a dump box.
Spray bars either mount to the tank, the pump, a slide-in bar, or are attached to the truck like a hitch receiver. There are many varieties of spray bars available, including single, 2-lane, and 3-lane spray bar assemblies.
The industry standard tends to be a solid straight stream nozzle that would be spaced evenly on a center bar and then also installed on the left and the right hand side wing bars, so to speak, so to cover the driver and passenger side lanes if applicable.
A lot of the equipment we got in the beginning had an 1.5 inch spray bar on them with 8 nozzles. And we found that a 2-inch spray bar with 16 nozzles gets your brine lines closer together, and that seems to work a lot better.
If your agency is using salt brine, it is typically more cost-effective to produce your own brine. Brine makers are produced by several different manufacturers and vary in their capabilities and production rates. Lower-end brine makers require manual production and are capable of producing 2,000 to 3,000 gallons of brine per hour. Higher-end models offer complete automation and are capable of producing 5,000 to 6,000 gallons of brine per hour. It is also possible to make your own brine maker.
There are models in the field that are built of fiberglass, stainless steel, or polyethylene are generally the 3 materials that you'll see. Some brine makers have a self-cleaning option. Some have a coupler that can attach to a loader, and others are simply just a flush-out style of brine maker.
Many agencies recommend using solar salts, which are a cleaner and purer form of rock salt. This reduces cleanup time and increases production rates. Salt brine should be mixed at a concentration of 23.3% salt. A weaker concentration can result in the road surface refreezing. A stronger concentration would lead to an excess of salt crystallization, which would mean wasted material and additional chlorides going into the environment.
Years ago in Southwest Colorado, building our salt brine program, we were seeing readings of 27-28% salt, and we were like, wow, we could supersaturate this salt. What we learned pretty quickly was all the salt precipitates out of the water and ends up clogging up your spray bars. So we learned that we needed to get that mixture correct at 23% salt. Otherwise, you run the risk of spray bars, nozzles clogging, hoses clogging, things like that.
Usage parameters and application rates. The use of liquid-only treatments will vary by road temperature, storm intensity, and precipitation type. It is important to get accurate weather information prior to starting a liquid-only treatment. For anti-icing with salt brine, the standard usage parameters are pavement temperatures of 15 degrees and higher, treatment within 48 hours of a storm, no rain in the forecast. Rainfall prior to a snowstorm event dilutes liquid applications, which reduces their effectiveness. However, if the rain is projected to be freezing rain, a liquid application can help delay the rain from freezing to the roadway until it is diluted. Additional applications will need to be made. For de-icing during a storm event, the standard usage parameters are pavement temperatures of 15 degrees and higher, 1 inch of snow per hour or below, drier snowfall. Wet snow can dilute liquid applications, which reduces their effectiveness. However, some agencies use liquid applications during heavy snow for breaking up snowpacks for plowing. The usage parameters for magnesium chloride and calcium chloride are different and will vary by manufacturer and product.
It's calibrating the trucks and having the operators judge what the storm's coming in, checking with the forecaster, seeing what it's doing, and from history and ability know what application rates I've had in the past. So having that historical information, knowing your section of the roadway, and knowing what your chemical is, can lead you to having a positive effect on the highway.
Liquids are applied to the roadway surface at an application rate that is measured in gallons per lane mile. Agencies have had success with application rates ranging from 20 to 80 gallons per lane mile, depending on conditions, timing, level of service, and other local factors.
If I'm going to get ½ inch of snow, moisture content 10 to 13% typically is where the range is. Let's say it's 25 degrees. You should be able to go out there and handle that with doing a 35 to 45 gallon sodium chloride application. You might need to come back and apply it again, and depending on what the melting action is.
If we're just maintaining, a lot of times we will shoot 40 gallons a lane mile as opposed to 80 gallons a lane mile based on weather conditions, temperatures, and your cycle times of your plows.
Shorter cycle times help reduce the possibility of the road refreezing. Longer cycle times increase this possibility as new precipitation melts and dilutes the liquid solution. A preferred cycle time is typically 1.5 to 2 hours. Cycle times include the time needed to refill the truck tanks and the deadhead time to the treatment route.
If the temperature is going down and the moisture is increasing, it can dilute the liquid sodium chloride out, and you can actually get into a refreeze situation. You have to boost up the amount of liquid that you're using. So you might go from that 50 gallon lane mile application, you might have to jack that up to 75 to 100 gallons. Or increase your cycle time so you can get back on the road and put more chemical down quicker.
This table shows general recommendations for application rates based on event type and pavement temperature. These rates are based on salt brine mixed at the standard ratio. For magnesium chloride, calcium chloride, additives, and blends, you will need to work with your suppliers to verify the correct application rates. It is possible to extend cycle times by supplementing the liquid treatments with an application of pre-wetted salts, as the granular slows down the dilution of the liquid treatment.
Depending upon the intensity level of the snowfall, you may have to go into a plow-only mode. At the end of a storm event is when it is most effective to use the direct liquid, because it really does help take off that final layer of snowpack that tends to stick to the roadway at the end of a storm, especially a high-intensity storm or a high snowfall level.
Public works agencies nationwide are working together to share information through organizations like the Clear Roads Group on winter road maintenance practices that are safe, effective, and economical. The advice and recommendations presented in this video are part of this shared knowledge. Agencies with successful liquid-only programs recognize that these types of roadway treatments are only effective under certain conditions and are part of a larger winter maintenance program. When used correctly, liquid-only roadway treatments are a safe and reliable solution for snow and ice prevention and removal.
It's a key component of what we do here in Prairie Lake, and it's a fixture on our trucks.